Now we're going to try to find the following limit. The limit as x goes to 0 of sine of x raised to 1 over x plus 1 over x raised to sine x. Okay, this is a JEE question. Okay, we're going to test these questions and see how they feel. So the first thing that we need to notice is that we need to have we can treat these two limits separately and we can see what we can get. Okay, so let's work on this one first here. Okay, the limit as x, we're gonna take x to x is gonna go to 0 from the right, because otherwise it's not gonna be defined. So here we have this one, we can write it as 1 over x ln of sine of x. Okay, so this is the first part here. Here, if we take the limit inside, here we're gonna get plus infinity. The sine of 0 is 0, and the natural log of the 0 is gonna be minus infinity. So we're gonna have plus infinity times minus infinity. Okay, but since we are working close to 0, we can make it work by using the equivalent statement or the equivalent functions. So sine of x is almost the same when we are close to 0. So they behave the same. Okay, therefore we can, this is some sort of the squeeze theorem or the equivalent form theorem. Okay, so here we have the limit as x goes to 0 plus of e to 1x ln of x. Okay, because the behavior is going to be the same and the sine of x is positive and very small, close to 0. Here we can write this one as the limit of e to ln of x over x as x goes to 0 plus. But here we know this limit. The exponential is continuous. We can enter the limit inside. So we have the limit, the exponential of the limit as x goes to 0 plus of ln of x over x. Here we don't need anything. We can just evaluate, and we're going to see why. Note that when x goes to 0 plus, the natural log goes to minus infinity, and x goes to 0. And therefore, we have minus infinity over 0 plus. So we don't need to do anything here, except that this limit is going to be the exponential, or minus infinity over 0 plus is minus infinity. Therefore, the exponential when x goes to minus infinity is 0. And therefore, this first limit is 0 here. Okay? Now, let's work the next one. The limit as x goes to 0 plus of 1 over x to the power sine of x. Here we can rewrite it by assuming x positive, e to sine of x ln of 1 over x. Okay, so now if we let x goes to 0 plus, this one is going to go to infinity. The natural log is going to go to infinity and sine is going to go to 0. So we can't work this one here, but we can. Oh, let me make the limit. The limit as x goes to 0 plus. So here we can use the L'Hopital's rule by rewriting this function. We can do the limit as x goes to 0 plus of e ln of x over 1 over sine of x. Okay, it's a bit messy, but so here e to ln of x over 1 over sine of x. Now if we take x as x goes to infinity here, okay, 1 over x here. This is 1 over x. So 1 over x is going to go to infinity, and the natural log of infinity is infinity. And as x goes to 0 from the right, 1 over sine of x is going to go to infinity. Therefore, we can apply L'Hopital's rule here. So we have the limit as x goes to 0. We're going to differentiate the first one. We're going to get minus 1 over x squared over 1 over x. And the one down is going to give us minus cosine of x over sine squared of x. It's a bit messy, but let's rewrite it one more time. The limit as x goes to 0. So we have minus 1 over x squared times x. Okay, this is the first one, times the sine squared of x over cosine of x. With the minus, this one is gonna go. So let me see, minus 1 over x squared times 1 over x, which is gonna give us, okay, and now we flip this one here. So okay, so we have the limit as x goes to 0 plus of sine of x over x times 1 over cosine of x. Okay, but we don't forget the exponential. This is e raised to this quantity, but since the exponential is continuous, we can take the limit inside. So it's going to be e limit of sine of x over x times 1 over cosine of x as x goes to 0 plus. Okay, here this is 1 and this is 1, and no, so sorry, so this one is going to be let me see, did I miss anything? So it's going to be 1 minus 1 over x squared times x. So it's going to be 1 I need a minus sign, some minus sign here. So it's going to be minus 1 over x squared over 1 over x over minus cosine of x over x squared. So it's going to be 1 minus 1 over x squared times x times sine squared of x over minus cosine of x. It's going to go here. We have 1 sine of x. Oh, I forgot the sign. There is a missing sign here. That's the problem. Okay, I missed the sign because I have sine squared. So here I have 1, but here I have 0. So I have e to 0, which is 1. I think that's the mistake I did here because I have sine squared. Sine squared, I missed it here. So I have to split sine squared into sine of x over x. This x is going to go with this x. So I have sine of x over x, and I need sine x over cosine of x. And this one is 1. We know this one, and this one is 0. So we have 0 times 1, but e to 0 is just 1. Therefore, this limit is 1. Okay, we always try to not make mistakes by reviewing and letting you see what mistake we make. We don't edit. Okay, we want you to see how we correct our mistakes. Thank you very much.